Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night. I'm your host, Wayne Zool. Welcome to the Astro Guy podcast. September is a great month for astronomy. The sun sets a bit earlier each evening, allowing us to enjoy the pleasant September evenings. Let's take a look at the planets this month. Mercury is very low in the west as the month begins, and spends the entire month lost in the glare of the sun. Venus starts the month very low in the east in the early mornings. It too will soon be lost in the glow of the sun before it emerges in the evening skies next month. The moon will be at first quarter on the 3rd. This presents a great opportunity to see many features on the lunar surface, especially near the terminator, or the line between light and dark on the moon. A great feature to look for with binoculars, although it will be easier to spot in a telescope, are 3 craters that sort of resemble a snowman. The craters are Arzachel, Alphonsus, and Ptolemaeus. Just above Arzachel, toward the terminator, is the Straight Wall, or Rupus Recta. This is a 1,000-foot-high cliff on the lunar surface that casts a shadow for just a few days each lunar cycle. See if you can spot it on the 3rd, 4th, and 5th. The moon will be full on the 10th, and it will reach last quarter on the 17th, and will be new again on the 25th. As the month comes to a close, the crescent moon will reappear in the west at sunset. How close to new moon can you spot it? Let us know. On the 1st of the month, at around 4 a.m. in the east-southeast, Mars is about 50 degrees above the horizon, shining brightly at magnitude minus 0.2. It is located just about 5 degrees above or northwest of the 0.8 magnitude red star Aldebaran in the constellation Taurus. Aldebaran is part of the V-shaped Hyades cluster of stars in Taurus. Mars and Aldebaran should fit in the same binocular field of view. How different do their colors appear to you? Through a telescope, Mars still appears rather small, spanning only 9.7 arcseconds, but with good seeing and some practice, you should be able to spot the south polar cap and some markings on the surface of the planet. By month's end, Mars will have grown to nearly 12 arcseconds across. It will continue to appear to grow until its opposition in December. On the morning of the 17th, Aldebaran, Mars, and the waning gibbous moon all form a straight line in the sky. This will make a nice sight visually, and it should appear very nice if you can photograph it. The planet that truly rules the skies this month is Jupiter. The largest planet in our solar system reaches opposition on the 26th. When this occurs, the Earth is directly in between the Sun and Jupiter, so Jupiter will rise when the Sun sets and set when the Sun rises. It is also when we are closest to Jupiter. Jupiter spends the entire month in the constellation Pisces, and rises much higher in the sky than Saturn when it was at opposition last month. Jupiter appears about 50 degrees above the southern horizon at around 1 a.m. on the morning of the 26th. But you'll be able to get good views of it once it's about 20 degrees over the horizon. Jupiter appears large in a telescope, spanning nearly 50 arcseconds, and it is bright, shining at magnitude minus 2.95 at opposition. In binoculars, you should be able to easily spot the 4 Galilean moons as they make their way around Jupiter. You can detect their motion in several minutes' time. However, this is easier to spot through a telescope. With a telescope, you should be able to spot the dark bands on Jupiter and, if it's facing us, the Great Red Spot. However, recent observations have shown the Great Red Spot to be shrinking a bit, and there's a dark ring around it. Can you see it? Saturn reached opposition last month, and is about 15 degrees above the horizon as darkness falls on the 1st. By the end of the month, Saturn will be about 20 degrees above the southeastern horizon as darkness falls. Binoculars should show Saturn as an oblong disk, while in a telescope you should be able to easily resolve the planet's rings. Try to spot Cassini's division, the large gap in the rings. Many observers will use this as a test for how steady atmospheric conditions are. Always beautiful in a telescope, Saturn is worth a look for sure. On September 1st, Uranus rises around 10:15 p.m., but it is best viewed well after midnight. At 5 a.m. on the 1st, Uranus will be about 65 degrees above the southern horizon and will be glowing dimly at magnitude 5.76. From a very dark rural location, you might be able to glimpse it with the naked eye. Any binoculars or telescope will be able to reveal Uranus, but it will appear relatively small, spanning only about 3.5 arc seconds. By the end of the month, it rises at around 8:15 p.m., making it easier to view late in the evening. In binoculars, it will appear as a greenish-blue star, while in a telescope, you should be able to make out the disk of the planet. Neptune reaches opposition on September 16th. However, Neptune appears faint, glowing dimly at magnitude 7.68, and at opposition, the planet only spans a mere 2.5 arc seconds across. It appears bluer than Uranus, and is easy to pick out based on its color compared to the stars that it's near. It's best seen in a telescope, but you'll be hard-pressed to make out any details on the planet. That's all for our tour of the solar system this month. Now we're going to revisit the constellation Sagittarius the Archer, which we touched on last month, and the tiny constellation Delphinus the Dolphin. As the month begins, Sagittarius is at its highest in the south. The constellation is supposed to represent an archer, but is most recognized by the teapot asterism. Sagittarius is host to the heart of the Milky Way, and all kinds of objects are visible within its boundaries, including nebulae, open clusters, globular clusters, and galaxies. Last month, we went over locating M8, M17, and M20, so we won't rehash them this time, but we will use M8 and M20 as a starting point to find our first object. Locate M8, then move to M20. Once you get M20 in your binoculars or telescope, just move half a degree north and then the same amount east, and you'll be looking at the open cluster M21. This cluster glows at magnitude 6.5, so you'll need binoculars to spot it. However, using a telescope should reveal several members of this young star cluster. M21 spans about 1/4 of a degree and contains more than 105 member stars, many of which are blue giant stars. However, only about 40 or so are visible with a telescope. The cluster is estimated to have formed about 6 million years ago, and is sometimes called Webb's Cross, as some people see a cross-shaped pattern of stars. M21 is one of the few Messier objects that is yet to be imaged through the Hubble Space Telescope. Our next object is big and bright, but with open clusters, that makes them tough to stand out, especially against the star-rich region of the Milky Way. M23 glows at magnitude 5.5 and spans 35 arc minutes, making it appear larger than the full moon. Made up of hundreds of faint stars, in binoculars it will appear as a hazy glow, while in a telescope at low magnification, you'll be able to pick out several dozen stars within the cluster. To locate M23, go 3.5 degrees north of M21, and then sweep 1.5 degrees west, and you'll be looking right at the cluster. The cluster is close, located about 2,000 light-years away, and is about 13 light-years across. It is best viewed at low power through a telescope, where dozens of member stars can be seen. Our next object is the open cluster M25. You can find it by starting at Caus Borealis, the star at the top of the teapot, and sweeping 6 degrees north and then about 1 degree east. This should put the cluster easily in your field of view on binoculars. Cataloged as the brightest open cluster in Sagittarius, it too can be tough to pick out amongst the background stars. The cluster shines at magnitude 4.6 and spans 26 arc minutes in diameter. Okay, maybe open clusters aren't your thing. How about globular clusters? Well, Sagittarius has its fair share of them for you to enjoy. The largest, brightest, and easiest to find is M22, located just about 2 degrees east and 1.5 degrees north of Caus Borealis. M22 is interesting for many reasons. It's relatively bright at magnitude 6.1, and it's large, spanning about 32 arc minutes in diameter. In binoculars, it will appear as a slightly oval glow. You'll need to view it through at least an 8-inch telescope to reveal any of its member stars, as the brightest member stars are about 11th magnitude. This globular cluster is one of the closest globulars to us, at only 10,600 light-years away, and it contains more than 70,000 stars. It is estimated to be about 100 light-years across, and astronomers have observed 2 black holes within the cluster using the Very Large Array radio telescope in New Mexico. M69 is next on our tour. Start at Caus Australis, or Epsilon Sagittarii, the star representing the bottom right corner of the teapot, and draw a line to 3rd magnitude Phi Sagittarii, the star representing the top left part of the teapot where it meets the handle. About 2.5 degrees along that line from Caus Australis is where M69 is found. In binoculars, you can spot it as a small, mottled glow. In a telescope, it will appear as a small round glow, and several member stars can be resolved. It has a combined magnitude of 7.6 and spans just over 10 arc minutes across. This globular is almost 29,000 light-years away and is only about 45 light-years across. Located 2.5 degrees east of M69 is M70. Interestingly, Charles Messier cataloged both of these clusters on the same evening. He spotted them over Paris on August 31st, 1780. M70 is very similar in size and brightness to M69. However, it is slightly fainter at magnitude 7.9 and slightly smaller at only 8 arc minutes across. You can spot M70 with binoculars, but again, a telescope will reveal its structure much better. Both M69 and M70 are about the same distance from us. M70 is a few hundred light-years further away. Both clusters are located near the galactic center of the Milky Way, with M69 a bit closer at 5,200 light-years from the center, while M70 is about 6,500 light-years from the galactic center. Our next object is M54, located just over 4 degrees south of Nunkai, or Sigma Sagittarii, the second brightest star in the constellation. Glowing at magnitude 7.7 and spanning just over 12 arc minutes in diameter, M54 is an easy target in binoculars. In a telescope, you'll be able to resolve many stars within the cluster. M54 is about 87,500 light-years away from us, and the cluster spans about 150 light-years across. To locate the next 2 globular clusters on our tour, you'll want to look for a cross-shaped asterism of 4th magnitude stars that is located 14 degrees due east of Nunkai. From the star that represents the bottom of the cross, sweep 1 degree east and then slightly less than 6 degrees north, and in binoculars you'll spot another faint, round, fuzzy cloud. This is M75. You'll need a telescope to resolve any of its member stars, but this is still a nice cluster. The cluster glows at magnitude 8.6 and spans 6.8 arc minutes. It is about 67,500 light-years away from us and is about 67 light-years across. Our last globular cluster in Sagittarius is a bit of an overlooked object, mostly because it is so far south, at minus 30 degrees declination, so it never rises very high in our skies in the U.S. To locate M55, go back to that cross of fourth magnitude stars. From the top star in the cross, sweep 4 degrees west and 5 degrees south, and you'll see a faint fuzzy ball in binoculars. Again, with a telescope, you'll easily resolve several member stars in the cluster. Brighter and larger than M75, M55 glows at magnitude 6.3 and spans 19 arc minutes. The cluster is located about 17,600 light-years away from us and spans 48 light-years across. Alright, maybe you've had enough globulars and open clusters for now. How about a galaxy? A very interesting galaxy. NGC 6822 is known as Barnard's galaxy, as it was discovered by E. Barnard in 1884. It is very similar in structure and composition to the small Magellanic Cloud, which is a satellite galaxy of the Milky Way. While Barnard's galaxy is not a satellite of the Milky Way, it is a member of the local group of galaxies that the Milky Way is part of. The galaxy spans about 1/4 of a degree and is dim at magnitude 9.3. You'll likely need an 8-inch scope under dark skies to catch a glimpse of it, but if you can spot it, it's definitely a notch in your observing belt. Edwin Hubble studied this galaxy and cataloged many of its member stars, including 11 Cepheid variable stars, which help us to measure its distance. To locate Barnard's galaxy, start at M55 and sweep north 16 degrees and then 1 degree east, and you'll spot the galaxy. Use low magnification, and you should be able to pick it out. Sagittarius is a large constellation, and as you now know, it contains a multitude of deep sky objects. Now let's take a look at a constellation that's quite a bit smaller, Delphinus the Dolphin. This little constellation lies just north of the celestial equator. 1 third magnitude star and 4 fourth magnitude stars comprise the brighter part of the constellation. To me, 4 of the stars make a kite shape, while the 5th star represents the tail of the kite. It's easy to spot by starting at Altair and going halfway to Sagitta, then sweep east about 10 degrees. The only deep sky object within easy reach of amateur instruments in Delphinus is Caldwell 47, which is also known as NGC 6934. This globular cluster glows dimly at magnitude 8.83 and spans about 8.5 arc minutes. A 6-inch telescope should reveal some of the cluster's member stars. The cluster is located about 52,000 light-years away from us. To locate it, start at Alpha Delphini, the brightest star in the constellation, and sweep southward to 4th magnitude Epsilon Delphini. Then sweep south another 4 degrees, and you should have the cluster in a low power field. That's all for our deep sky tour this month. Make sure to tune in later this month, as we'll have a special podcast dedicated to our moon. It should be a lot of fun. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for current and past episodes, as well as other surprises. Please subscribe there as well. Please consider leaving us a review on your podcast platform. It really helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem. Seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.